Let's take a look at number 1 in section 6.6. We want to find an equation of the parabola that's given. It says use vertex form or factored form of the equation, whichever is more appropriate. Okay, so if I'm looking at this graph of the quadratic, out of the two forms, I would say the easiest one to use is factored form, because we can tell what those x-intercepts are pretty clearly. Okay, the vertex has non-integer coordinates, so that may be a little bit harder to tell. So we're going to start with factored form, which is y equals a times x minus r1 times x minus r2, where r1 and r2 are the x-intercepts. Okay, so in my case, one of the x-intercepts is -4, so x minus -4, and then the other is -3, so x minus -3. Okay, and simplify, so a times x plus 4 times x plus 3. Well, the only other thing that we need to do is determine a, what the leading coefficient, which does a couple of things to the graph. It stretches the graph or compresses it, or it reflects it. And so we can tell, because this graph is flipped upside down, that it opens downward, that a is going to be a negative number. So now we just need to choose one other point on the graph and use it to help us determine a. So I'm going to find another point that I think has integer coordinates. And so this one right here, it looks like it does pass through the intersection of the grid lines. And so that's at -2, -2. Okay, so when x is -2, y is -2. So we're going to substitute -2 for y and -2 for x. So we have -2 is equal to a times -2 plus 4 times -2 plus 3. Okay, so that is -2 equals a times 2 times 1, or -2 equals 2a. So 2 times 1 is 2. So -2 equals 2a, and divide both sides by 2, and we get a as -1. Okay, so lastly, the equation that we're going to enter is going to look very similar to this one, y equals a times x plus 4 times x plus 3, except we're going to replace a with -1.